Zombie Apocalypse.
Okay, so today's topic is the continuation of load provisions and load combination. So this time, let us try to take a look, the necessity of the reinforcement inside a concrete. So that's why we're going to discuss crack and uncrack stage of concrete, the principle, and some code provisions behind. So get ready to be neurorized. Okay, so here is a simple figure of a beam when subjected to a load, no? So, as we already know from our theory of structures, so when a beam is being loaded by whatever type of loading is being applied, either gravitational or lateral, it suffers from deformation, no? Kapag gravity loads, it suffers from, of course, deflection, okay? Because the beam may go down, so dependent on the application, no? Of course, we already connected in my past video lectures in theory of structures, okay, that the moment and deflection has relationship, no? That's why methods of calculations for deflection is being generated, and there's so many to mention. But for the meantime, let us try to analyze under elastic bending. So, meaning that the beam has the capacity to resist load. So, the question would be, what would happen to the concrete beam when we try to make the loads, no, let's say W, become larger and larger and larger? Okay, now before we try to understand the nature of being crack and uncrack, no, of a particular beam, we should be aware that during our strength of materials, no, let's say we have this cross-sectional area, so it follows hook slope axial deformation, right? So therefore, the capacity of the beam can go back to its original position, or its original cross-sectional area. So that's why we observe linearity, okay, of stresses, okay, as well as strain, no? So that is only good if and only if you are following under straight line direction. However, due to the property of concrete beam that it is brittle, so there will be some value of magnitude force W or uniform load that may potentially produce break or cracking of the beam. So therefore, there will be a point in question, when will the beam crack, no? When it come to the property of the beam. So will it be the property of the load? Will it be the property of the concrete itself? Or should I say, what kind of serviceability condition are we going to observe? Well, deflection is one, and the others are, let's say, the shrinkage, the creep, and so on. But most likely, bending failures upon reinforced concrete beam will happen like this, because we are aware that when we talk about concrete, okay, it is brittle, and this is what we call strong, okay, in tension, but weak, oops, that's not strong in compression, sorry, okay, and weak in tension. So, by the way, the beam will deflect like this, okay, due to the understanding of gravitational load, okay, say W. So, there will be a case like, of course, for positive bending, compression above, tension below. So, most likely, the tension side will suffer cracks, okay. These cracks may result to unsafe feature of the beam, assuming that it is non-reinforced, no? Yan ating consideration. So, meaning to say, there can be a point in the design that the beam will require reinforcement due to the fact that weakness in tension, there should be a complementary. So, what material can complement, no, the weakness in tension? That is what we call steel reinforcement, no? So that's why our discussion for today will cover up to what extent that the beam needs or will necessitate reinforcement, no? Yan yung pinaka key feature ng ating concrete beam for us to better understand why is there a need to reinforce our concrete beam. So by starting with this topic, we will try to understand and identify when and when not the concrete beam should be reinforced or be unreinforced. Okay, so again, let's take a closer look. No, what if the beam is being reinforced? Okay, now, of course, prior to cracking, we will realize that the stress strain will follow hook slope axial deformation. Meaning, if we were to try to observe, let's compare it with the illustration before. Kanina, wala siyang reinforcement, Wala siyang reinforcement. Pero ang stress strain diagram ay the same. Meaning, the reinforcement here is what we call parang hindi siya nag-act for the stresses itself. So therefore, there can be some concepts here, one of the concepts here, that we can try to neglect no reinforcement, such that the action of the reinforcement does not contribute to the changes of the stresses and changes to the strain of that particular concrete beam. So, paano natin malalaman kung kailangan natin i-neglect or hindi? Okay, let's answer that later as we proceed with the code. But of course, after cracking, syempre nagka-crack na, no? We understand that below the neutral axis, okay, this is under tension, will most likely perforate, okay? The understanding is the compression force, okay, will just only be the main effective force, while the tension force will from the concrete will be neglected since the introduction, okay, of the tension reinforcement will now be the main feature of this reinforcement guide. So therefore, steel alone will carry most of the tension, meaning if there are tension forces to be carried by the concrete under tension, okay, maliit na lang talaga kasi nawala na nag-crack na, pwedeng pa ganito, okay, or pwedeng pa ganyan. So therefore, the concrete will be suggested, no, or the concrete under tension is suggesting that we need to neglect the tension force carried by the concrete since it should be carried by the tension reinforcement already. That's why after cracking, you will identify that there will be no continuation of the stress. However, that Fs signifies the strength of the steel alone, but there will be no effective stress for concrete under the shaded region. Okay, so that's the meaning. Okay, I'll try to shade under violet so that you would realize that this is the missing piece of the strain diagram. But the strain, of course, it should be continued because it suffers shortening or lengthening. Okay. Okay, so that's the figure that we are talking about. So as I go back to the original figure, I want to show that this is the original stress diagram if we are talking about after cracking. So meaning there can be two stages to consider, the before and after cracking. So the after cracking, we will try to call that the crack stage, okay? The before cracking is what we call the uncrack stage. So let's talk about the what we call non-crack linear stage. Why linear stage? Because linear stage file is being adopted by the local code NSCP 2015, which is what we call the code base or the linear based design. There's what you call non-crack, non-linear, and it is already a higher code-based solution, which is performance-based. I am delimited only to discuss the linear stage. No? So assuming that we have this non-crack beam, concrete beam, so meaning the whole concrete area performs. So therefore, there can be some allotment that we may consider the entire concrete itself. Okay. So by that sense, then, if you have some reinforcement there, okay, installed, then we would like to deduct the equivalent area that is being displaced by the material steel. So that's why it becomes N minus 1 times AS. If you are to be strict in calculating the performance of concrete, assuming that, let's say, you're thinking about there is a hole here, and then I'll try to insert this reinforcement. However, our code suggests already that if you are installing reinforcement and it is found to be non-crack, you can neglect already the reinforcement as if there's no steel residing on that particular region. Since the tension of the concrete side is performing. So meaning, small participation of the steel rebar, as you will try to experience that. So in calculating, so it will be of small participation. So therefore, the code allows us to neglect the effect of the steel bar whenever we are trying to understand the non-crack stage. I'll try to point out and stress out those sections in our code. This is for the non-crack. However, if the stage now becomes cracked under linear, what will happen? Okay, so therefore, there will be no perforation, or there will be some loose area of concrete under tension. So meaning, para nangyari is the effective area only is the compression, assuming positive bending, and the tension will now be dependent on the tension reinforcement that is being installed. So meaning you have to neglect already the effect of the concrete under tension. Okay? So therefore, in this illustration, it becomes n minus n times AS, since n represents the modular ratio to discuss, and AS is the steel rebar. So we need to eventually idealize the transformation. No, this is what we call the concrete stress transformation. No, so as for us to deliver the idea of a singular material. Okay, stress transformation ito. Why there is a need to do this, no? Kasi nga po, ang bakal is stronger than concrete, so we need to adjust to make the stronger into a weaker material, to make it all weaker material of similar type. So we are converting the steel into just like an equivalent concrete, and then calculate whatever is required. So therefore, we don't need to deduct a value of 1 to n, since the concrete itself, no, this concrete is already being perforated or being neglected due to the fact that it cracks already. So there's no functionalities observed already for serviceability state, even for deflection or other types. So therefore, it can be neglected, no, as mentioned earlier. So that's why we are in the consideration of n times AS. Okay, that's the idea why it exists. For the n minus 1 times AS, it is under uncracked linear stage for better understanding. Okay, but again, the code will tell you later that if your beam is under the uncracked linear stage, you may neglect the effect of the n minus 1 times AS, since the concrete under tension already acts significantly compared to the tension reinforcement acting for tension, which is already tolerable or no sense at all. Let's try to take a look on some codes required, that is needed to understand the cracking and uncracked states of concrete. So under section code 424.2.3.5 for non-prestress, so we're talking about non-prestress since there can be two types. So prestress and non-prestress. So effective moment of inertia I sub E. This code actually is utilized for us to calculate deflection, but why should I use this in understanding crack and uncrack? In the deflection, already shows that the beam or the element will crack, ano? So, essential po ang deflection sa pag-understand ng crack. But we will not try to compute this since I will dedicate a separate discussion for this particular topic. What we're going to look for is the crack and uncrack only. So, this is the equation, yes, but notice that the main element of understanding the deflection is the cracking moment. That is our main focus, and as well as the critical inertia I sub CR. So, how do we calculate the cracking moment? No? M sub CR muna. Is equal to F sub R, IG over YT. Mamaya, I'll try to show you the terms and definitions as well as to make sure use to understand this equation. Okay? So, this equation for 24.2.3.5b will be the main course of computing the capability of the concrete to resist tension, no, and if there's a necessity to install reinforcement. Na the main reason is due to, of course, isa lang po sa larin yan, yung pagkakaroon ng crack. Okay? The crack that may be a direct influence of deflection. Okay. So, tabi lang muna natin ito formula dito para at least medyo may recognition tayo mamaya as we discuss the next content. Okay. So, we are in the interest of what is F sub R. Okay. So, ang tawag sa kanya is a modulus of rupture. Siya yung capability to rupture or to crack. Okay. So, taken as 0.62 lambda square root of Fc prime. So, si Fc prime ay may definition ng compressive strength of concrete while lambda is in accordance to section 419.2.4, or this is actually a code to review that I'm going to show you later. Okay, how do we assess lambda? This will be also similar to the next topics that we are going to discuss. Basta't pag may lambda, ito ang treatment. Lambda signifies code 419.2.4, okay? Under lightweight concrete, kasi meron tayong different types of concrete, no? May lightweight, may normal weight, at saka may special type dependent on the class mixture that you are going to impose, and some composites that you are going to put on that particular concrete mixture. Now, under 419.2.4.1, to account the properties of lightweight concrete, no, a modification factor lambda is used to as a multiplier of square root of Fc prime in applicable provision in this code. So, nakakalat po ito, ibig sabihin. Now, how do we assess lambda? So, under 419.2.4.2, may table po tayong pinapakita for all lightweight, fine, blend, sun lightweight, coarse blend, and normal weight. Automatically, pag hindi po naman mention kung anong type of concrete yung ating pinag-usapan, it is presumably a type of normal weight unless specified. So if there will be no identification, then we are going to use normal weight condition. However, if there are some conditions to define na wala po dito sa mga sinabi, may clause naman po si NECP, sabi dyan, linear interpolation from 0.75 to 0.85 is permitted based on absolute volume of normal weight fine aggregate. So dito, mag-generate ka na ng sarili mong equation based on linearity. So it's so easy naman to identify, basta't meron ka munang understanding sa values na nakukuha mo due to testing. Then you can now evaluate the true value of lambda. Okay, ano ba yung mga notation and terminology na makikita natin? So, si Fc prime na ginagamit dito, okay, is what we call the specified compressive strength of concrete. Ito yung ginagawa nating concrete mixture. Okay, si F sub R, as mentioned, is the rupture modulus. Ito to, yan. Yan lang po yun, okay? Yan. Now, mark in violet, the I critical, I sub CR. So, this will be actually be used in understanding stresses. Okay? So, ICR can be IG and ICR cannot be IG dependent on the notation, on the situation. IG represents the moment of inertia of that particular axis in centroidal, neglecting, take note, neglecting reinforcement. So, take a closer look kanina and explain natin na under Uncrack linear stage, so, di ba may n-1 times AS? And then I mentioned, dahil dun sa parang tolerable effect niya, you can try to neglect the reinforcement by removing that n-1 times AS already. And then go back to just only a typical Varignon-solved cross-sectional area. So, that n-1 AS can be eliminated, no, by the sense of the code. Now, M sub A is what we call the maximum moment to understand applied that is found on the beam. So meaning it is directly dependent on the load applied. Now, M sub CR is one of the degree of measurement, okay? Degree of measurement in assessing cracking. And Y sub T is the description of what? The distance from the centroidal axis of cross-sectional neglecting reinforcement to tension phase. So let's say if you have this beam, okay, Kasi may bakal ka dito to represent. So, sinasabi na neto, ang laging YT, tanggalin mo muna yung reinforcement, i-assume mo muna ng gross, meaning uncrack, tapos ito yung YT, or any location where tension can be found. Depende sa nature of bending. Ito yung nangyayari lang kung ang given natin na bending is positive moment. Pero like cantilever or continuous beam, where negative moment is larger than positive moment, magbabaliktad po yan. Kapag negative moment, okay, pag gano'n naman po yung bending niya, okay, so therefore, tension is located above, compression is below. So ito po yung YT, extreme fiber location up to the neutral axis, solved by Varignon. Okay? Now, how do we know if the beam is cracked or uncracked? Simple lang po. If the maximum moment M sub A is less than or equal to the capacity to resist crack or M sub CR, or pwede kasing gamitin yung maximum bending stress or maximum fiber stress due to bending is less than or equal to the rupture stress or rupture modulus, it can be said that it is under uncrack. So meaning the reinforcement is not a necessity under tension. So we don't need to install reinforcement. And then we can assess that the critical inertia is already equivalent to the gross moment of inertia. If the maximum moment naman is more than the cracking moment, or in the other sense, if the maximum fiber stress under bending is more than the rupture stress or the capability to resist rupture, nag-exceed ka doon, no? Then you're now under crack. So the meaning is you need to install reinforcement and understand the stress involved. And then we can say that the critical inertia is no longer equivalent to the gross inertia. Thus, we need to calculate the true moment of inertia under critical or cracking condition. So we will expect by the second condition, assuming that this is the first, this is the second. Under the second condition, the critical inertia most likely be less than the gross inertia. Malaki po ang potential na ito ay mas lumiit kasi nung nag-gross ka, yung bakal niya hindi na-assess. Okay? So therefore, the end outputs that we need to understand here, ano yung stresses of the top and fiber stresses to be ready to understand deflection. In the near future, we will try to understand this main equation for us to completely idealize the serviceability state of concrete under crack. So therefore, this is actually the methodology for us to find out if there's a need to reinforce concrete. And then, if there's a need, doon na po tayo pupunta sa topic ng susunod, which is singly reinforced concrete beam under USD of our NECP 2015. But for now, let us take a closer look on how do we apply these codes and the senses of the linear crack and linear uncrack. So by our next discussion, we will try to show you some sample calculations and application to an uncrack and crack stage of a concrete beam. So that's it, no? Salamat, no? I hope that you have learned something today. So next video lecture will showcase the application of all these codes discussed in a single problem, showing you how to treat a beam if that is crack or under uncrack stage, okay? But for today, please subscribe to my YT channel. Don't forget to hit the like and share button below. And again, as a tradition, you have been neurorized, and see you in our next video lecture. Coming up next is the application of this particular code in a problem showing how do we know if the beam is cracked or uncracked. See you in our next video lecture.